Okay, so this will be the third example that we do on these rational inequalities. So again, make sure you watch the first two videos before trying this one. So let's get right into it. So if you notice in this example, we're dealing with a quadratic on both our numerator and denominator. However, it is already set to 0, so we're good there. But what we want to do here is we want to factor both our numerator and denominator before we find our points of interest. All right, so let's go ahead and do that. So if I were to factor this, right, my numerator is going to become, I'll get x plus 1 times x plus 1, right? And on my denominator, I'm just going to get x minus 3 and x plus 3, right? That's just the difference of two squares, and then again, it's greater than or equal to 0. So now I have it all factored out. That's what you want to do first. And now we can find our points of interest. So what I'm going to do here is I'm going to erase this one and replace it with what we factored. So I'm just going to go ahead and erase this. And then we're going to go ahead and replace it with what we got. So we have x plus 1, x plus 1, and then we have x minus 3, x plus 3, and again greater than or equal to 0. Alright, so let's go ahead and find our points of interest. So again, we're going to take our numerator, set it equal to 0, and solve. Now notice here I have x plus 1 and x plus 1, they're the same factor, so I only have to write it one time, okay, because I'm going to get the same answer. So what I'm going to get here is the following. I get x plus 1 equal to 0, and when I solve, I get x is equal to negative 1. This is going to be a point of interest, okay? Now doing the denominator, again we do the same thing, but just remember, instead of setting it equal to 0, we set it not equal to 0, because again, remember, we can't have a 0 in our denominator because then it will be undefined, right? So we set it not equal to 0 in that case. So let's do our first factor. We get x minus 3 not equal to 0, and when we solve it, we get x is not equal to 3. Okay, there's one point of interest. And then we get x plus 3 not equal to 0, and when we solve it, we get x is not equal to negative 3. There's another point of interest. So we have 3 points of interest, right? We're now ready to go ahead and create our number line. So let's go ahead and do that. So just putting on the number line. Here we go. And again, you want to go from least to greatest with your points of interest. I'm going to start at negative 3. So negative 3, and then we have negative 1. And then we'll go ahead and just call this here 0, right? And then we have 3. So let's call this 3. All right. So at this point, we want to test our regions. And in this particular problem, right, we're going to have one region. That's our first region. All right, we'll call that region 1. Region 2 will be right here, right? Region 3 here, and region 4 here. So again, region 1 is to the left of negative 3. Region 2 is in between negative 3 and negative 1. And then region 3 is in between negative 1 and 3, right? And then region 4 is to the right of 3, right? Those are going to be our test regions, okay? And before we go any further, we want to go ahead and put either a closed or open circle on our points of interest. So looking at our first one, x is equal to negative 1. That means we can use a closed circle because it's equal, right? It's equal to. Now, on x is not equal to 3 and x is not equal to negative 3, that's going to be an open circle, right? And we've talked about this in the past videos. Now we're all set to go. So what I'm going to do is just pick an integer and each one of my test regions, test it out and see what happens. And from there, I'll be able to derive my solution in interval notation, okay? So let's go ahead and start with region 1. I'm just going to pick negative 4. Again, you could pick anything you want to the left of negative 3. So I'll just pick negative 4. So what I'm going to do is plug in negative 4 wherever I see x, right? So let's go ahead and do that. So I'm going to get negative 4 plus 1 times negative 4 plus 1. And then I get negative 4 minus 3, negative 4 plus 3. And this is greater than or equal to 0. Now we can go ahead and just simplify it down. So on our numerator here, we're going to get negative 3 times negative 3, right? On our denominator, this becomes, we get negative 7, and then we get negative 1, right? And this is going to be greater than or equal to 0. And I can see here, right, to the left, when I go ahead and simplify this down, my answer is going to be positive, right? It's going to be positive, so I don't even have to go any further. I know that since it's positive, it's going to be greater than or equal to 0, and that's going to be true, right? So what I can do here is I'm just going to go ahead and put T for true in region 1. Again, we use this at the end when we write our final solution in interval notation. All right, let's try region 2 now. So let's erase this. So doing region 2, we're going to get the following. So I'll just go ahead and put in negative 2, right? So let's go ahead and plug in a negative 2 wherever I see x. So again, we're just picking an integer that's in between negative 3 and negative 1. So I picked negative 2. And then on our denominator, I'm just writing it in. All right, so when we go ahead and solve this, we get the following, right? We get negative 1 times a negative 1. And then on our denominator, we get a negative 5 times a positive 1. And this is going to be greater than or equal to 0. Right, so when I look at this one, I don't have to go any further. I can see that my end result here is going to be negative, right? When I go ahead and simplify this down, it's going to be negative. And we know that a negative is not going to be greater than or equal to 0. So that tells us that region 2 is going to be false, right? So it's false. So we're going to put F here for false. All right. Okay, let's go ahead and try region 3 now. So let's go ahead and just erase this. And for region 3, we can pick 0. That's going to be extremely easy to work with. So let's go ahead and do that. So we're just going to plug in a 0 wherever we see x. And I'm just going to go ahead and write it out. So if I plug a 0 here and a 0 here, we know it's just going to be 1 and 1, right? And same thing here. If I put a 0 here and a 0 here, it's just going to be negative 3 and 3, right? And this is going to be greater than or equal to 0. Again, I don't have to go any further. I can already see that the end result here on the left is going to be negative, and we know that a negative is not going to be greater than or equal to 0. So for region 3, that is also false, right? So we want to go ahead and just put false here. All right. Now, something to consider here. If you look at region 2, it was false. Region 3 was false. However, look at negative 1, right? I have here x can be equal to negative 1. So even though you tested region 2 and region 3, be careful of this because this negative 1 is actually going to be part of your solution. And you can confirm that by simply plugging it in, right? So for example, if I plug negative 1 into my inequality, I get the following, right? So let me go ahead and do that. And you'll see it right away. I plug in negative 1 here, plus 1, right? Negative 1 plus 1. And then I get a negative 1 minus 3, and negative 1 plus 3, greater than or equal to 0. Well, I can already see on my numerator, right, negative 1 plus 1 is 0, right? 0 times anything is 0, and then I'm doing 0 divided by whatever I get on my denominator here. That's just going to be 0, right? 0 divided by anything is 0. So essentially what you're going to have is 0 is greater than or equal to 0, and that's true, right? So you need to include negative 1 in your solution in the end, okay? So just keep that in mind. All right, let's test our last region, and that's going to be region 4, right? So let's erase this. Okay, and just testing region 4, let's go ahead and just pick 4, right? So just plugging the 4 in wherever we see an x, so we get 4 plus 1, 4 plus 1, and then we get 4 minus 3, 4 plus 3, this is going to be greater than or equal to 0. And again, I'm going to stop right there because we can see that our end result here is going to be positive. Anything positive is going to be greater than or equal to 0. So for region 4, we're going to go ahead and put a T for true, all right? We're now all set to go ahead and write our final solution in interval notation. So let's go ahead and do that. So just erasing this. And now just writing our final solution. So again, going left to right. So I'm going from negative infinity, right? I use a parenthesis because I cannot be on negative infinity. I can go up to it though. And then I'm going to negative 3. So again, another parenthesis because it is an open circle. And then if you look at region 2, that's not part of our solution, right? But we said negative 1 is, right? But there is a gap here going from region 2 to negative 1. So to show that, we use a union. So we have a union, and then we're simply just going to put x is equal to negative 1. That's it, right? And then looking at region 3, that's not going to be part of our solution. It was false, right? Region 4 is, so again, there is a gap here going from negative 1 to our next region here, 4, right? So we need to put another union, right? And then just writing our final part here, we're going to have parentheses, right, 3, because again, it is an open circle, comma, positive infinity, right? And then again, another parenthesis, because we're going up to infinity, but we cannot actually be on it, right? So this here is going to be your final answer. So we can go ahead and just box it in, right? So there is the final solution in interval notation. Okay, so that is solving rational inequalities.